You wake up, and a sharp smell of rotten eggs hits your nostrils. You look around wildly and realize the smell isn't coming from your mom's cooking downstairs. It's super hot, and there are giant red clouds churning in the sky. Yikes! You're on Venus! The planet is named after the ancient Roman deity of beauty and love, but sadly, its smell doesn't correspond with its name. The atmosphere of Venus is made up mainly of carbon dioxide, but thick clouds of sulfuric acid completely hide its surface from prying eyes. Sulfur has a really bad stench, which causes the surface of Venus to smell like rotten eggs. Gross! The atmosphere on the planet is also really hot and thick. The carbon dioxide traps a small amount of energy from the sun that reaches the planet's surface. This greenhouse effect has made Venus one of the hottest places in the solar system. So, the good news is, you wouldn't be able to smell the planet's stench, as humans can't survive on its surface. Well, that's a relief. Almost all other planets in our solar system only have a super small selection of different scents on their surface, unlike Earth. But what about our moon? The scent of the moon is similar to something called smokeless powder, which is a propellant used in firearms. Basically, the dust on the satellite smells exactly the same as when a shot is fired. Apollo 17's pilot Eugene Cernan says he could smell it straight after removing his suit from the spacecraft. But nobody's exactly sure why it smells like this, as there's zero similarity between the two substances. Smokeless powder is made up of a mixture of two things with very complicated names: nitroglycerin and nitrocellulose. Black powder, its older counterpart, is made of charcoal, saltpeter, and sulfur, which makes it smell in a very specific way, but not like rotten eggs, despite the sulfur content. Moon dust is made up of a bunch of things that primarily come from broken meteorites. This includes iron, magnesium, and calcium, but it doesn't contain either of the things in smokeless powder, or black powder either for that matter. And what's weirder is that moon dust samples brought back to Earth have been odorless. Experts say the smell could have been the dust reacting with oxygen or water inside the lander. The smell could also be due to the temporary release of charged particles from the sun that had become trapped in the dust. Mercury is the planet closest to the sun, but it doesn't really have a strong smell. This is because the atmosphere is so thin and scattered. Mars. Like Venus, it's another world that doesn't have the best scent ever. It's a good thing we can't breathe its air. The red planet smells like rotten eggs, again caused by sulfur. If human colonies did move to Mars, it looks like we'd have to burn a lot of scented candles to cover the smell. But the good news is that the sulfur quantities are pretty small, so the smell wouldn't be too overwhelming. Jupiter also has a whiff of eggs, but also smells a bit like it's been mixed with cleaning products. This is because its atmosphere is a mixture of hydrogen sulfide and ammonia. But what you smell basically depends on where you are in the planet's atmosphere. Some regions have higher concentrations of ammonia. This substance is used in a bunch of cleaning products here on Earth. So areas high in ammonia could have that strong burning stench of cleaning fluid. A lot of people also say that ammonia smells like a pair of dirty socks that haven't been washed in forever, so it's for sure best to avoid these parts of the planet. Other areas have a lot of hydrogen sulfide, and because it contains sulfur, these parts would also smell like rotten eggs. The third and final scent you'd find on Jupiter is bitter almonds, or marzipan, just like the kind your grandma puts on cakes around the holidays. This is in areas where a substance called hydrogen cyanide is most common. Jupiter is the biggest planet in our solar system. It's so big that it's 2.5 times larger than all of the other planets in the solar system combined. It's also the fastest spinning planet in our solar system. Next up, the ringed planet, Saturn. Its atmosphere is made up of about 96% hydrogen and 4% helium. Yes, that's the gas that makes your voice go all squeaky. Both hydrogen and helium are odorless, so Saturn probably doesn't have a strong smell. It does, however, contain traces of our good friend ammonia. That's the smelly sock gas. Saturn's atmosphere also has a bit of phosphine, which can sometimes smell like garlic or decaying fish. So there might be a slight bad stench in the air. The thickness of Saturn's atmosphere is only 37 miles. For comparison, our atmosphere here on Earth is almost 300 miles thick. Saturn also has some of the strongest winds in our solar system. They can reach a whopping 1,118 miles per hour. One of Saturn's moons is called Titan, and it has a super odd scent. Its atmosphere is made up of something called benzene, which has really weird effects if inhaled by us humans. It can make us feel dizzy and make our ears ring. It doesn't actually smell that bad though. Its scent is kind of like almonds. Now it's time to take a dive into Uranus. This gas giant has gotten itself a reputation as the smelliest planet in the entire solar system. There's a lot of stinky stuff floating around on the planet, and its upper atmosphere is made up mostly of hydrogen sulfide. Yep, that's the molecule that makes rotten eggs smell so nasty. But the temperatures are so severe on Uranus that you'd pass away even before you've had a chance to smell anything. Uranus's atmosphere is a staggering negative 392 degrees Fahrenheit. That's so cold that it would almost instantly freeze anyone. The final planet in our solar system is Neptune, and it's just as cold as Uranus, at negative 373 degrees Fahrenheit. Neptune also smells pretty bad. Some scientists say it smells like seaweed that's washed up on the shore. Others say again that it smells like rotten eggs, because it contains a bunch of hydrogen sulfide molecules. But like on Uranus, you're not going to have time to take in the nasty smell. As the most distant planet from our sun, it's dark, freezing cold, and has supersonic winds. No one would be able to survive when faced with one of the icy hurricanes which are constantly raging on the planet. Neptune is the only planet in our solar system that's not visible to the unaided eye. Well, we've covered the planets, but what does space itself smell like? Space is mostly a vacuum, which means it doesn't actually contain any molecules, so there's basically nothing to smell. But some astronauts have actually said space smells a bit like fried meat or hot metal. This smell is most commonly reported in the first instance after the astronauts re-enter their spacecraft. They shut the airlock, repressurize, and then remove their helmets. But there are a bunch of theories suggesting that the meat smell isn't actually space. It's either from the equipment operating the airlock or from interactions between space particles and the spacesuits. Astronaut Tony Antonelli said that space definitely has a smell that's different than anything else. Talking about his fellow spacewalkers coming into the ship, another astronaut, Don Pettit, said he noticed that this smell was on their suit, helmet, gloves, and tools. One thing we definitely know that has a smell, though, is comets. If you could inhale a big whiff of a comet, it's likely going to make you feel lightheaded and maybe even sick. The odor from comets is like a mix of rotten eggs, old smelly socks, almonds, and it'll also have a hint of biology dissection lab. On the bright side, though, the presence of hydrogen sulfide and sulfur dioxide in the scent would block your sense of smell after the first sniff. So at least the stench wouldn't linger. But the bad news? Nearly all the ingredients that make up a comet's smell are toxic. So you're probably going to want to avoid coming into contact.
Back when Apollo missions were launched, astronauts returning from the moon claimed that moon dust, the gray sand-like dust covering much of the satellite surface, smelled and tasted, yes, they actually tasted it, like gunpowder. What the stuff moon dust is made of is nothing like gunpowder. About half of its composition is silicon dioxide glass from impacts with meteorites. They hit the surface of the moon at incredible speeds. Whoa! The high temperature makes the topsoil fuse into glass, and the impact shatters it right afterwards, creating the gray and clingy dust. The rest of moon dust ingredients are minerals such as iron, calcium, and magnesium, while old-fashioned gunpowder consists mainly of saltpeter, charcoal, and sulfur. In other words, moon dust shouldn't smell like gunpowder, but it does. Besides, when astronauts brought samples of it back to Earth, there was no smell left at all. One explanation could be that the moon is similar, in a way, to Earth's sand deserts, like the Sahara. It's extremely dry and arid. When you sniff the air in a desert, you don't smell anything. But if you get caught in the rain there, the moisture will raise all kinds of odors from the ground that were previously trapped in the dry sand. With moon dust, it might be similar. While on the surface of the moon, it doesn't smell at all. Not that the astronauts could sniff at it wearing their spacesuits, though. But when brought back inside the landing module, the dust came into contact with moisture in the air and started emitting its strange odor. Another reason for this could be a reaction of moon dust to the solar wind. Ionized particles from the sun hit the bare surface of the moon and stay there. There's no thick atmosphere to protect it from those ions, so they travel freely right to the ground. They're very lightweight, so they can fly off and sort of evaporate from the slightest of nudges. And when astronauts took the moon dust samples to the landing module, those particles could have started moving around and giving off the specific smell. This might also explain why the samples didn't keep their odor when brought back to Earth. Since the particles are so light, they might have flown off the samples already in the landing module, and when they were placed in airtight containers, there were little or no ions left on them. Another explanation is that those airtight containers weren't so airtight after all. Moon dust is basically very small crystals with extremely sharp edges. They unexpectedly made tiny cuts in the seals, letting in air and moisture, and so the ionized particles leaked out of the containers. Scientists believe they should study moon dust on the surface of the moon itself to find out everything about its properties. Now, there are hundreds of thousands of craters on the surface of the moon made by falling asteroids, but one of them drew a lot of attention. It turned out to not be just an impact crater, but a tube, looking most like an entrance to a cave system. Scientists found a specific echo pattern that suggested there was a hollow area beneath. They discovered more echo patterns at a couple of places near the hole, so there could be more lunar tubes there. But in this big tube, you could place an entire football field. Researchers believe there could be an entire geological wonderland under the surface. It could be a good shelter for astronauts landing on the moon, or even be a harbor for a lunar colony. No one ever managed to stay on the moon for more than 3 days because of the conditions on the satellite. Wide range of temperatures, low atmosphere, no magnetic field would protect life on the surface from things like radiation or solar wind. Astronauts wear spacesuits. They can't protect them over long periods of time, but a lava tube could. When a lava flow cools, it gets a hard crust, which later thickens and creates a roof over that same lava. It continues to flow, but when it stops, the channel can drain, and that's how an empty tube appears. Our planet also has lava tubes, but they're not as big as the one found on the moon. Back in 1178, I wasn't around then, at least 5 people in England claimed they had seen the moon split into 2 from its upper tip. It was in the shape of a crescent at the time of the event. When the crack widened, fire started blazing from it, which the single monk who chronicled it described it as a flaming torch sprang up, spewing out fire, hot coals, and sparks. Then the moon started shifting around and pulsating, but soon stopped and turned a slightly darker shade. The event didn't receive much attention from scientists, though, until the second half of the 20th century. Researchers studied the chronicle and figured out there was a huge 14-mile-wide crater on the surface of the moon at about the spot described in the book. Only a very large asteroid could have left such a scar on the satellite's face. And when they investigated it more closely, they found out it was pretty recent by astronomical standards. In fact, it really could have appeared about 800 years ago. But in that case, millions of fragments from the asteroid and the moon would have hit the Earth as well, and then people would have seen an incredible meteor shower. It would have been very bright, and the memories of it would have definitely been in the archives. But that didn't happen. In addition, many scientists argue that the crater isn't as young as it might seem. The most popular and justified theory is that it's about 1 to 10 million years old. If it had appeared as recently as 800 years ago, parts of the surface of the moon in and around the crater would still have been warm from the impact. The most likely explanation of what really happened back in 1178 is that observers were extremely lucky to see an asteroid falling towards the Earth and burning in our planet's atmosphere. The spectacle would have been incredible, and seen from a proper angle, the burst of the asteroid could have really looked like it was the moon exploding. That would explain why there were so few witnesses of the phenomenon. The right spot to see the show, as they did, was only a couple of miles wide. As for real events on the moon, water and oxygen were unexpectedly discovered on it not long ago. Water might have been brought to the satellite by asteroids hitting its surface, many of them carrying H2O molecules, and those that are left on the moon in tiny amounts after the impact. There's precious little water there, though. By comparison, even the Sahara Desert has more of it than the entire moon. Oxygen is also present as separate molecules floating around, so you still can't breathe on the moon. Solar wind brought them there. Waves of energy from the sun travel at extremely high speeds through space, scrape oxygen from the upper parts of our atmosphere, and carry it further. Eventually, the wind with the oxygen molecules reaches the moon. And that's where something incredible happens. The moon starts rusting. There's plenty of iron in the lunar soil, and when it's exposed to oxygen and water, it naturally rusts. Some parts of the moon have actually already turned slightly reddish. They're regions where there's the highest concentration of molecules. If this process goes on long enough, in the distant future, the moon will look like Mars. It will turn orange-red. Yes, the signature color of Mars came exactly from the corrosion that began there thousands and thousands of years ago, when there were rivers and seas with water and an atmosphere with oxygen. Another unusual phenomenon is the blue and red lights on the moon. They can be seen when it's crescent-shaped. The flashes come and go very quickly, almost like lightning. And in fact, that's what they basically are, electric bursts. Tidal forces are to blame for this. They cause mechanical stress buildup in the rocks. This can produce an electric field, which creates the blue flashes that have surprised many amateur astronomers. But still, there's so far been no green cheese discovered there, or moon pies for that matter. Disappointing, I know.
If you were floating in space, no one would be able to hear you whisper, talk, or even scream in horror at seeing a giant asteroid coming towards you. It's not only that you'd be far away from Earth, but sound needs space to travel through. Sounds are just vibrations of molecules and atoms in some medium, like water or air. Your body will pick up sound waves through the ear canal and to the eardrum. Vibrations we receive then transform into electrical signals so our brain can understand and recognize them. Frequencies of sounds humans can hear are between 20 to 20,000 hertz. Sound travels 4 times faster in water because molecules are closer together than in air. Naturally, it travels faster through steel than both water and air. The loudest natural sound on our planet is one made by an erupting volcano. Not 100% certain, but scientists believe the eruption of Krakatoa in 1983 was probably the loudest sound humankind ever had the chance to hear. It exploded with enormous force, destroyed its island, and released 20 million tons of sulfur into the atmosphere. People even heard it 3,000 miles away. It would be like someone producing a sound in New York and people hearing it all the way in Ireland. Sound can take many forms, but humans are most familiar with it in the form of pressure waves that move through the air. Sound goes more slowly through heavy gases and colder air. It travels faster through lighter gases, for example, helium. There's no water or air in space, so the sound doesn't have anything to travel through. Our atmosphere consists of 10 trillion atoms, which is like dense soup creating a way for sound to travel. And there are only 10 atoms per cubic meter up in space. That means space is empty and silent. But it wasn't always like that. The universe is 10 to 20 billion years old. It appeared as a result of the Big Bang. It wasn't an explosion that started from just one single point, but rather space appearing everywhere in the universe at the same time. Back then, the whole universe was like a hot ball of plasma. It was much thicker than today, so the sound could pass through it. As the universe was forming, it produced shock waves, and they, in return, produced a cosmic rumble, way deeper than things our ears can normally detect. These are the actual and the first sounds the universe ever produced, at the stage when it was still forming. Scientists decoded them and pitched them up to a version we can actually hear. As time went by, the universe was stretching. Today, it's a lot wider, emptier, and quieter. It's good for us, though. If sound traveled through space with ease, we would constantly hear loud explosions, crackles, moans, and other sounds space bodies make out there. The sun isn't silent either. Here's the sound of its vibrations created by its loops, waves, eruptions, and other activity. The sun creates trillions and trillions of watts of sound energy, something like pulsation, low heartbeat. It helps researchers discover what's going on inside of the sun and understand its layers. If it wasn't muted for us on Earth by a lack of air in space, it would be like hearing a jackhammer all the time. If you and your friend were taking a walk on the surface of the moon, you wouldn't be able to hear each other talk. No air, no sound. But that doesn't mean the moon itself doesn't produce any sound. When the first spacecraft landed on the moon, it caused crashes which later led to moonquakes. Scientists took a chance to measure vibrations going through the moon to figure out its internal structure. They realized they caused vibrations that lasted longer than they expected, and longer than any similar vibrations on Earth. It was like those moonquakes were producing the sound of a ringing bell. When we have earthquakes, moisture in the ground acts like a sponge. It absorbs the energy of the waves spreading around until it ends their effects, which is why water eventually stops the earthquake. The moon is dry, more like a solid rock. Moonquakes are less intense, but there's no water to stop them, so vibrations just go back and forth through the moon. The solid rock stops them at some point, which is when the ringing stops too. Let's see what happens with the sound on different planets. Neptune, Uranus, and Saturn are mostly made of helium and hydrogen. These gases are way lighter than the atmosphere on our planet, so your voice there would generally come out in a higher pitch. But each planet has its layers that make differences in sound. Neptune has its murky depths, Uranus its methane clouds, but they're both freezing, made of gas, and have ice particles in their atmosphere. Saturn, also a gas giant, boasts wild, raging storms. Saturn's biggest moon, Titan, is the only one known for having a real atmosphere. It's thicker than the one we have on Earth. It's very cold there, and it rains liquid methane. In 2005, researchers sent the Huygens spacecraft that managed to record incredible audio you might find familiar. The sound of winds, but billions of miles away from us, on Titan itself. If you were there, you might even hear the sound that reminds you of a waterfall. In reality, it's flowing liquid methane. Moving to Jupiter, it doesn't have a solid surface either. It's made of gas that becomes denser the deeper you go. At some point, it even turns into a liquid. The sound is different in each of those layers. Jupiter is actually pretty noisy and has bizarre sounds. It creates intense radio storms with powerful lightning bolts. While there, you'd hear their echoes of echoes, just going back and forth. Mars, its atmosphere is way thinner than Earth's, which means there are not many molecules for sound to travel. Winds can get pretty fast, like our hurricanes, but on Mars, they would feel like a gentle breeze. You wouldn't necessarily hear the storm though. You'd maybe hear the dust as it gets picked up and banged against your spacesuit. In the thin atmosphere, your voice would be much quieter, and it wouldn't travel far. Someone could be standing next to you and screaming, and you'd probably hear nothing. Low-density air actually makes our voices sound higher-pitched, but the cold temperatures, like on Mars, slow down the sound so it would balance out again. Your voice there would sound a bit distant and blurry. And imagine listening to an instrument like a guitar or piano there, like some muffled melody from a dream. Sound on Venus is kind of the opposite of Mars. Venus has a dense atmosphere, much denser than ours, something between water and air. There, you'd hear sounds like when you're underwater. The environment is a bit different with 900 degrees Fahrenheit and 100 tons of atmospheric pressure. But let's say you have a magical spacesuit that protects you from getting crushed or scorched. While on Venus, you'd hear thunder. 40 years ago, a spacecraft successfully landed on its surface and managed to go almost an hour before it shut down. It picked up these amazing sounds of strong winds. If you started talking on Venus,
your voice would first hit the lower pitch because of the dense atmosphere.
But it would then sound higher because hot air increases the speed of sound. It would be kinda distorted and muffled together with the sounds of thunder around you. Mercury is a rocky body with no atmosphere, so standing on its surface and talking would be like trying to talk while floating in space. Useless. Those are almost vacuum conditions, which would make you think Mercury has no sounds at all. Still, you can hear them, though not in the air. The rocks. Put your ear against the ground. Maybe a Mercury quake is coming. The universe is a place connected by light. Light can go anywhere from any spot in space, but not the sound. So not only do we have a planet that supports life, but offers a wide palette of sounds. Even without us, it wouldn't be a quiet spot. A light breeze gently caressing treetops, earthquakes, volcanoes, deserts. The ocean with its waves on the surface and scary sounds deep below. Up there, it's a quiet mystery. But down here, it's true magic.